This is a Key Stage 3 video from the topic chemical structures, and we're looking at the reactions of metal with acid. And our general equation is that when we add a metal and acid together, we get a salt and hydrogen. And the example we're looking at is adding magnesium ribbon to hydrochloric acid, and that makes magnesium chloride, which is left in the boiling tube, and hydrogen gas, which is released and collected, as you can see in this picture, in a measuring cylinder. We can also see we've got a balanced symbol equation, so Mg for magnesium, HCl, so big H, big C and small l for hydrochloric acid. MgCl2 is the structure of magnesium chloride, and then H2 for the hydrogen. And because we've got two hydrogens on this side of the equation and two chlorines on this side of the equation, we've put a big 2 in front of the HCl to say there's two molecules of HCl, and that balances everything out. So we've got one magnesium on each side of the equation, two hydrogens on each side of the equation, and two chlorines on each side of the equation. And we've got this setup of equipment where we've got a conical flask with the acid and magnesium ribbon reacting together. And then we've got a delivery tube delivering that hydrogen into that inverted measuring cylinder. Inverted means upside down. So we've got a measuring cylinder, filled it with water, put it into a trough, and then the hydrogen gas bubbles through and we can collect that hydrogen gas. And what's really good about using a measuring cylinder is that we can actually look at what volume of gas have we collected in a fixed amount of time. So we could let the reaction run for 1 minute and look at what volume of gas has been produced in that 1 minute, or we could say, okay, let's time it to see how long it takes to collect, say, 100 millilitres or 100 centimetres cubed of hydrogen. Okay, and that hydrogen can be tested using a lit splint and you get a squeaky pop. Okay, so hopefully we should get a good squeaky pop from our reaction. So I have some 2 molar hydrochloric acid and I have some magnesium ribbon, and I'm going to put them together in this boiling tube. I don't want to overfill it, so I want to have enough of a reaction but not allow the reaction to go over the top of the boiling tube. And I've got quite a few pieces here, maybe 5 pieces of magnesium ribbon. So I'm going to put those into my acid, immediately fizzing, releasing lots and lots of heat because it's an exothermic reaction. We'll talk more about that later. And I'm letting the air come out of that delivery tube, and now I think it's probably hydrogen, so I've got an inverted boiling tube here with water in it, and I'm collecting hydrogen. Okay, so I allowed some of the air that was already in the tube to exit, and now I should have a good amount of hydrogen in there, hopefully pure hydrogen, rather than being contaminated or weakened with the air. And then I've got a lit splint coming on its way, so this is really, really warm, okay, releasing lots of energy as it's an exothermic reaction, creating in there magnesium chloride and obviously hydrogen gas. So here goes. And then we get our squeaky pop. So here we are filling the boiling tube again with some more hydrogen, hoping to get a slightly more impressive pop than we just did, a bit more of a squeaky pop. If there's pure hydrogen there, we should get a really nice, loud, squeaky pop. Okay, ready? Much better. Not as squeaky as I wanted, but definitely louder. Okay, let's look at this reaction in a bit more detail. So we've got the magnesium reacting with the hydrochloric acid to make magnesium chloride and hydrogen. The magnesium started off on its own as a pure metal element. It's in group 2, So when it becomes the ionic compound magnesium chloride, it's given up, it's lost 2 of those electrons, okay, because it's in group 2. And we know from our little saying oxidation is loss of electrons and reduction is gain of electrons, oil rig, that if the magnesium has lost electrons, then it must have oxidized. Okay, so the magnesium has oxidized in this reaction. Quick reminder that hydrochloric acid is actually hydrogen chloride in water, and when it goes into that water, it dissociates. Okay, so they split up and become separate ions, H+ ions and Cl- ions. So we've got these positive hydrogen ions kind of floating around in the water of the hydrochloric acid, and as that becomes hydrogen gas, it actually gains an electron back, and we say that the hydrogen has been reduced because reduction is gain of electrons. Okay, so remember our oil rig, oxidation, that's what's happening to the magnesium, is loss of electrons because it loses those electrons when it becomes the ionic compound magnesium chloride. Reduction is gain of electrons, which is what's happened to the hydrogen, because as hydrochloric acid it was an H+ positive ion, and it's now gone back to being an element, so no charge. And because reduction and oxidation have both occurred in this reaction, we refer to it as a redox reaction. Okay, hope you found that useful. Thank you.